Good day, math learners! Welcome to Session 10, Properties of an Ellipse. In today's session, we will talk about the properties of an ellipse described by the equation which we were able to derive in Session 9. So, before we begin, let me remind you to subscribe in my YouTube channel and click the notification bell so that you get notified whenever I post new video lessons online. Let's begin! Let us try to focus on the features of an ellipse with the equation x squared over a squared plus y squared over b squared equal to 1. Alright, this is the equation that we were able to come up with when we derived the equation of the ellipse that we have illustrated in the previous session. Okay, so number one, this ellipse has its center at 0, 0. If you can still remember the figure of this ellipse, it looks like this. Let me have it this here. Okay, so this is our y and this is our x. This was our one of the foci. This is the other focus, and we have the vertex here, v sub 1 and v sub 2, and we have w sub 1 here and w sub 2. Okay, so when we graph it, it looks like this. Okay, so from here, the distance from our focus to the center of our ellipse is C. Okay, and so is this. Okay, this is also C, and the distance from the center towards our vertex is A. Okay, and the distance here from the center to one of our this w sub 1 and from the center to w sub 2 is B. Okay, so this is the figure of this equation, x squared over a squared plus y squared over b squared equal to 1. Now, the center obviously of this ellipse is at 0, 0. Moving forward, the foci, our focus, this point, and this other focus here, f sub 2, would have the coordinates from this point to that is C, and this point to that is also C. So our y here, obviously, because the focus is at the x-axis, our y is 0. Therefore, the focus has its coordinates at plus minus C, or just at negative C, 0, and positive C, 0. Next, let's come now to our vertices, this v sub 1 and v sub 2. So the v sub 1 there, the points v sub 1 and v sub 2 are the vertices of our ellipse. And v sub 1 has coordinates. If this point to this point here is A, then v sub 1 has coordinates negative A, 0, and v sub 2 has coordinates A, 0. Okay, we can just write this actually as plus minus A, 0, and these are already the coordinates of our vertices. Alright, and if you're going to look closely, the vertices, this v sub 1 and v sub 2, and let me use another color so that will be emphasized. If you're going to look closely to that, let me use the yellow ink. Okay, so v sub 1 and v sub 2 and the center are collinear, and so is this focus here, f sub 1, and the other focus, f sub 2. These 4 points are collinear. Okay, if you have noticed that, the 4 points are collinear. Therefore, our vertices you have to take note of this, that our vertices are collinear with the center and the foci. And each vertex is a units away from the center of our ellipse. This V sub 1, the segment joined by V sub 1, this segment here, let me draw this back again, this one, this segment actually joined by V sub 1 and V sub 2 is actually called the major axis of the ellipse. Therefore, the major axis is joined by the two vertices of the ellipse. So, V sub 1 to V sub 2 is the major axis of the ellipse. Okay? Since V sub 1 to V sub 2 is equivalent to 2a, because from the center to one of the vertices is a, and so is this other vertex here, therefore V sub 1 to V sub 2 is 2a. This 2a actually divides the ellipse into two equal parts. Which parts are this? The upper part of our ellipse, this portion, okay, this portion here, and this lower part, okay. These are the two portions which are divided by our major axis. The major axis divides the ellipse into two equal parts. Now let us move to our W sub 1 and W sub 2. So if V sub 1 and V sub 2 are called the vertices of the ellipse, W sub 1 and W sub 2 are called the co-vertices of the ellipse. So the coordinates of our co-vertices is this one. If the center up to W sub 1 is B, and so is from the center to W sub 2 is also B, therefore the co-vertices are located at, the x here is already 0, it's at negative B and at 0 positive B, or we can just write that into plus minus, 0 first here, plus minus B, okay. And if you're going to look at that, this segment here joined by the two co-vertices from W sub 1 to W sub 2, this segment is collinear with the center. It passes through the center of the ellipse, but it's not anymore collinear with the foci, okay? And if you're going to look closely, this segment is actually perpendicular to the major axis, and this segment is called the minor axis of the ellipse. Alright, therefore we can say that W sub 1 to W sub 2 is the minor axis of the ellipse. So the endpoints of the minor axis are the co-vertices, while the endpoints of the major axis are the vertices. And this segment, the minor axis, is perpendicular to the major axis. And also, the minor axis divides the ellipse into two equal parts as well, just like the major axis. It divides the ellipse into two equal parts. The left part, this part here, is equal to the right half of the ellipse. And again, if x is equal to 0 here, if x is equal to 0, then the y coordinate of our co-vertices would be plus minus b. Just like the vertices, if y here is equal to 0, then x here would be plus minus a. Alright? And since we know that A, let me emphasize it here, since we know that A is greater than B and we let A to be greater than B, if that is the case, since V sub 1 to V sub 2 is equal to 2A and W sub 1 to W sub 2 is equal to 2B, therefore the major axis, you have to remember this, the major axis is always longer than the minor axis. And these are the features of our ellipse. That's it, math learners! I hope you have learned something in this session as we explored the properties of an ellipse, the features of an ellipse. In the next session, we will try to work on one particular problem pertaining ellipse, try to find its focus. We'll try to find its focus, its foci, its vertices, its covertices, and graph the ellipse. Okay? Stay safe always. Bye!